Hi, and welcome to Dr. V's Chemistry Webcast. Today, we're talking about significant figure rules. These are rules that we're going to use in terms of interpreting and analyzing measurements. So we need to know them. Luckily, they're pretty easy, and you're going to pick them up really quickly. Let's start right with rule number one. Rule number one says all non-zero digits are significant in a measurement. Okay, so if it's not zero, it's significant. So the measurement 24 grams has 2 sig figs. There's 2 non-zero digits. 9 liters, 1 sig fig. 4,571 seconds, think it for yourself, right? It should be clear to you that there are 4 sig figs. 6.7892 meters, 5 sig figs. All right, I think we're good, right? I think we're ready to move on. Let's go on and talk about rule number 2. Rules 2, 3, 4, and 5 are all about zeros. We need 4 rules just to deal with zero. Okay, let's go on. Rule number 2 deals with what I call captive zeros. Captive zeros are zeros that are sandwiched between non-zero digits, and they're always significant. So, for example, if we have a measurement of 105 meters, there's 2 non-zero digits and a 0 in between them. There are 3 sig figs. And we can actually have more than one captive zero in between non-zero digits, so 7,006 seconds. Both of those zeros are significant. There are 4 sig figs. 200,007 grams. All right, if that's your measurement and that's how it's supposed to be reported, there are 6 sig figs. All right, so let's go on. We're ready. Captive zeros are easy to identify. Let's go on and look at Rule 3. Rule 3 deals with what I call leading zeros. Now, these are placeholder zeros, but specifically, they're placeholder zeros at the left of a measurement, and they're never significant. Now, we would only typically write these with very small numbers where there's a bunch of zeros and a decimal point, and then our non-zero digits. We don't normally write leading zeros with large numbers that are greater than 1. So, if I have a measurement of 0.01 joules, which would be a tiny amount of energy, those 2 zeros there are leading zeros. They're never significant. There's just 1 sig fig. If I have 0.000356 grams, so a very tiny mass, the leading zeros aren't significant. Right? And there are 3 sig figs with those non-zero digits. Now, we can have more than one rule at play at a time. So I can actually have leading zeros here. Do you see I have 3 leading zeros? And then I have 2 captive zeros between the 5 and the 3. All right? So the leading zeros aren't significant, but the captive zero is. So there are 4 sig figs in that measurement. All right, now we're ready for Rule 4, more with zeros. All right, Rule 4 is probably the trickiest of the rules. Rule 4 deals with trailing zeros, and these are zeros that are at the right side of a measurement. And they are sometimes significant. Sometimes, yes, and it depends on whether or not there's a decimal point anywhere in the number. And it doesn't matter if the decimal is at the left of the number or the right of the number. Trailing zeros only count if the decimal is written in the number. So, if my measurement is 10 grams, say I was measuring, and I could only measure every 100 gram intervals, and this is how I had to write my measurement down, there's only 1 sig fig. That trailing zero at the right of the number is not considered to be significant. Just the 1 is significant. If it were written as 10 point, which is indicating that I could, my mass, my balance was marked to every 10 units, right? There's a decimal point now, and so now I have 2 sig figs. So it's really about the presence of the decimal. All right. If I have 10,020 seconds as written, the captive zeros between the 1 and the 2 are significant, but the trailing zero at the end is not. And so I have 4 sig figs in that measurement. But if it's written 100.20 meters, right, that decimal now means all the zeros are significant. The captive zeros and now my trailing zero are significant, and I've got 5 sig figs. Okay. And one final example, if it's 0.50 meters, I've got a leading zero, which is never significant. I've got a trailing zero and a decimal. So the right-hand zero is significant, but the leading zero on the left is not, and there are 2 sig figs in that measurement. Okay, there's one more rule. Are you ready? One more rule. Rule number 5 says, for measurements that are reported using scientific notation, all the digits in the coefficient are significant. So the coefficient are those numbers before the times 10 to the whatever, and they're significant. So if it's written 1.2 times 10 to the third meters, all right, I'm not showing my trailing zeros here. I'm just saying that the 1 and the 2 before the x are both significant. There are 2 sig figs. If it's written 4.00 times 10 to the minus 7th grams, all right, the 4 and the 2 zeros before the x are all significant because they're in the coefficient. All right, the leading zeros are sort of implied with the 10 to the minus 7th grams. I don't have to show them here, but I have 3 sig figs because there are 3 digits written in my coefficient. 6.02 times 10 to the 23rd seconds. All right, so now I've got a captive zero in my coefficient, but that's okay. I still have 3 sig figs here because all the digits in the coefficient are significant. All right, now let's wrap up with some tips and tricks. Here's a situation that shows up sometimes. Sometimes there are measurements where there are trailing zeros, and some of them are significant and some of them aren't. And how do we handle this? Sometimes this comes up from calculations that we've done. Sometimes it's the nature of the measuring device, and we find ourselves in this situation. So, if the number were 202,000 liters, but the estimated digit is in the hundreds place, so not all of my zeros are significant. How can I show this? Well, I've got 2 ways. One is that I can choose to write it in scientific notation, right? So I could write 2.020 times 10 to the 5th liters, and that would work, right? I'm showing 4 sig figs, but not all of my trailing zeros that were significant. Or I can write a bar over the last significant zero. So I can write a bar over the zero in the hundreds place and write it in that way. So that would also be acceptable. Either one's fine. I'm good either way. So let's just wrap up here, okay? When you're recording the measurements, all of those measured values from the measurement, including that estimate digit, are significant, and you're going to write them down in your number, all right, and in your measurement with the unit. So you read that off the scale, or if you estimate it, and if it falls into those 2 categories, then it's a significant figure. The other thing I wanted to mention before I close is that counted values have infinite significant figures. Now, that's not a big deal right now with measurements, but it does become an issue when we start doing calculations. They're exact numbers. There's no estimation involved, and therefore, when we get into doing calculations, something with a counted value has infinite sig figs. It's not going to limit how we do that. So when we get into calculations, that's going to show up again. All right, this is a really good stopping point, and we're going to end here.